Okay, so then the next thing we're going to talk about is function composition. All that means is you're going to take one function and plug it into another one. That's it. So if you look at this terminology, we have f, and that little o in the middle means of. So f of g of x. And if we actually write it as function notation, all we're saying is you're taking the g of x function and you are subbing it into the f of x function. So x goes into g, and whatever you get then goes into f. So it's just taking it down the line. Taking your g of x function, plugging it into your f of x function. So then let's take a look at this. All right, so let's look at these two functions now. F of x is equal to 2x minus 1, and g of x is equal to 4 over x minus 1. And what we're going to do is take f of g of 2. So if you run it down the line, we're going to plug 2 into the g of x function. Then the value we get from that is what you're going to plug into f. You are not going to find f of 2. You are not finding that. What you are finding is f of g of 2. So start from the inside and work your way out. So this is really f of, if I plug a 2 in for my g of x function, I end up with 4 over 2 minus 1. So if I'm looking at this now, so I have 4 over 2 minus 1, well, that's just going to be f of 4 divided by 1 is 4. So now I'm actually taking 4 and plugging it into the f function. So then that is now 2 times 4 minus 1. So notice what we have here. This inside part is our g of 2. And then once you figure out your g of 2 actually equals 4, and that is what you're plugging into your f. Then you just solve that. So you end up with f of g of 2, and so you have 8 minus 1 giving you 7. It's a chain, it's a composition. You run it through both of them that you're looking at. It's not, and I can't express this to you enough. You're never going to plug this 2 value or whatever value it is into the farthest away function. It's got to be run through the machine. You got to run it through the first part of the machine. It does work, and then you run it through that second part of the machine. Good, let's try another one. Okay, we're going to take these same two functions, but look at what I'm trying to find. G of f of negative 3. So that means, regardless of the order that your functions are given, pay attention to what's happening here. Negative 3 actually goes into the f function first, then into the g function. Good, so pay attention to that whenever you go through and you look at these. So, let's do around there. I end up with g of f of negative 3. Now, I personally like this notation because I know these two outside set of parentheses is what I'm going to, whatever's on the inside of that is what I plug into my g function. So it kind of keeps me organized where I know I'm working inside out, kind of like order of operations, if you will. So we're working through the inside. So now I'm going to plug in my negative 3 into my f function. So 2 times negative 3 minus 1, and do work. So g of negative 6 minus 1. So I'm really finding g of negative 7. And that is what I plug into my g of x function then. So I have 4 over negative 7 minus 1. So that is 4 over negative 8, giving me a negative 1/2. So g of f of negative 3 is actually a negative 1/2. Pretty cool, right? It's not that big of a deal. You're just going to take one and plug it into the other. Let's check this out. Okay, let's take a look at this example then. I have f of x is equal to the square root of x and g of x is equal to 4x plus 2. So I want to find f of g of x and its domain. Okay, so here's the deal. When you're looking for the domain of these functions, you have to start with your original function. So the very first one that's listed in this instance, my very first function that's listed is f. So that's where we're starting with this. If I have the square root of x, what's the domain of the square root of x? Yes, it has to be greater than or equal to 0 because remember that's one of our big fat no-nos. So my domain for this one is going to be from 0 to infinity. What's the domain of g of x? Yeah, there's nothing going on with that one. Good. So it's negative infinity to positive infinity. Cool. Okay, so the domain of my composition has to also be in the domain of f of x because that is what is written first. Okay, so keep that in mind as we go through this. Let's go ahead and find our composition, and then we're going to make that determination. So if I want to find f of g of x, that means I'm going to take my g and plug it into my f. So I'm going to take my g value and plug it into my f. So this is really the square root of 4x plus 2. So here I don't have a value, I'm just taking my one function, my g of x function, and replacing the x in my f of x function. A common error I see is multiplication. This is not multiplied. This little o in the middle here tells you it is composition. You have to sub it in. You're not multiplying those together. That is something different. So here I have my new function. Here's my composition is 4x plus 2. So the domain of f of x is from 0 to infinity. That means the domain of my composition also has to fit in that. So let's take a look at this thing. If I want to find the domain, I'm going to take 4x plus 2 and set that greater than or equal to 0. So I'm going to subtract 2 from both sides and divide everything by 4. So x now has to be greater than or equal to a negative 1/2 because we're reducing that fraction. So having the 4x plus 2 greater than or equal to 0 satisfies my conditions for f of x. So here I have to have f of x where 0's to infinity, and so I have 0 over here, and so that takes care of it. Good. So now if I'm looking at the domain of my f of g of x, we use the value we found. Greater than or equal to a negative 1/2 translates to the domain is from negative 1/2 to infinity in interval notation. Cool. Now let's check this one out. Since we found f of g of x in its domain, now let's find g of f of x and its domain. So this means I'm going to go the opposite direction. So I'm going to take my f of x function and plug it into my g of x function. So then g of f of x is going to equal 4 times the square root of x plus 2 because I've plugged my f of x function into the composition. Cool. So my g of x function, the domain is from negative to positive infinity, so we've just got a free-for-all basically. So now what's the domain of this function? Remember, it is only restricted what's underneath the radical. The 4 and the 2 in this problem have nothing to do with my domain. So this 4 and this 2, that's fine. There's nothing wrong with those. The only thing I'm concerned about is what's underneath the radical. Yeah, so then what does that make my domain? From 0 to infinity. Great job. Cool. We got this thing. One more point that I want to show you is look at what happens here. Does the order matter when I'm talking about composition? Look at what I have. So up here on this first problem, you end up with 4x plus 2 all underneath the radical. For the second one, you have 4 times the square root of x plus 2. Are those the same? No. Yep, you're exactly right. They are not even close. So something that I want to definitely point out to you, when you're doing a composition, the order matters. That's a great big deal. So when you're doing a composition, the order certainly matters. The order matters. Are you doing f of g of x, or are you doing g of f of x? That makes a huge difference. All right? Cool. There's your composition of functions.